Hello everyone, my name is Matthew Lurtz. I'm a PhD candidate in civil and environmental engineering. I work for Dr. Gates and Dr. Morrison. Today I'm talking about a low-cost DIY ecosystem monitoring station that we've installed here in these fully irrigated as well as the stressed irrigated fields. Before I begin talking about my research today, as we all know that at the beginning of 2020, the pandemic began, which actually upended some of the funding of my research as well as the ability to travel in and around Colorado, specifically southeastern Colorado. So I just want to say I'm extremely thankful of the Irrigation Innovation Consortium, specifically AJ Brown and its representatives at IIC, for giving me essentially a research site, a spatial location that has real integrity in order to apply my DIY low-cost sensors. The main objective of my research is to test the durability and longevity of these DIY sensor networks that have been applied in this agricultural ecosystem. And the end game there is to essentially attack the scalability of deploying sensors in a natural ecosystem or an agro-ecosystem at with cost-effective solutions. In my analysis for this research, my science questions in general revolve around testing the quality of the sensors applied in the field, the quality of the data collected by those sensors, and the correspondence of those sensors, the correspondence of the DIY low-cost sensors to commercialized sensors in an agricultural ecosystem. The major components of my low-cost DIY monitoring station they're threefold. One of them is a soil moisture monitoring sensor, which is a Soil Watch 10. The second one is a SHT31 by Adafruit, is a temperature and relative humidity sensor that will measure within canopy temperature and relative humidity. And the third one is a infrared thermometer, a narrow view IRT sensor, or infrared thermometer, meant to capture actual green leaf temperature. I've installed 2 of these monitoring stations in the fully irrigated field behind me, as well as 2 stations in the stressed or drought stressed field as a way to check for differences between our 2 different crops, our 2 styles of watering our crop. The soil moisture sensors are placed at a depth of 30 centimeters and 50 centimeters, which means I have 2 soil moisture sensors per monitoring station. The IRT sensor is set up to take the leaf temperature of these corn crops, and there's also an SHT31 sensor, which is a temperature and relative humidity sensor that's installed within the canopy inside of a radiation shield, so gathering micrometeorological data within the canopy. The future directions of this research are to deploy these sensors and to test these sensors again in a natural ecosystem in southeastern Colorado, essentially in a more remote location. Another direction will be to take the data collected here and analyze it within a stochastic framework.